Yes, hi students. So in this video, I'm going to explain the program for congestion control using leaky bucket algorithm. So this experiment comes under this computer networks laboratory 17 ECL 68. So this is experiment number 5, part B. In this video, we are going to see the program using C for congestion control using leaky bucket algorithm. So here you consider the scenario for leaky bucket algorithm. First, we are considering the leaky bucket with water, a leaky bucket with water. Here, whatever may be the input flow, whether it's slow or fast, first it's going to fill the bucket and the output. Okay, here a small hole will be there. So the water drips out of the hole at a constant rate. Whatever may be the input flow, whether it's slow or fast, that output rate is constant here until the bucket is empty. So it's going to fill the water. It's going to fill the water and we'll get the output in a constant rate. If the bucket is full, then it's going to spill the water outside and the wastage of water takes place. And if there is no input from the tap, then output becomes empty. So we won't get any output if the bucket is empty. Let's consider the same scenario for network. Here, the interface containing the leaky bucket. Assume that the host computer sending the packet in unregulated flow. We are getting the packets in unregulated manner. Means sometimes we'll get only one packet and sometimes the host computer will send 10 packets at a time. Okay. So in order to avoid this unregulated flow, we'll use this leaky bucket concept here. It will store all these packets in the bucket. Then it will send the output in a constant rate, that is regulated flow. We'll get the output in a regulated flow manner. It will send the data packets to this network in a regulated flow manner. Here also there are two cases. If until the bucket is empty, it's going to store all the packets here. If it is full, then then waste of packets takes place. And if it is empty, the host is not sending any packets, then we won't get any output here from the bucket. Okay, whenever its bucket is empty, we won't get the flow of packets. Okay. So this is the scenario for this leaky bucket algorithm. The same concept. So using this concepts, we are going to write the program in C. Okay. Here the main concept of leaky bucket algorithm is that the output data flow remains constant despite the variant input traffic. Whatever may be the input flow, whether it's slow or fast, okay, we'll get the output constant rate, such as water flow in the bucket with a small hole at the bottom. We'll get the output in a constant rate. In case of bucket contains water or packets, then the output flows a constant rate. While if the bucket is full, any additional load will be lost because of spillover. Whenever if the bucket is full, then obviously that spillover takes place. Either it will lose packets or water. In a similar way, the bucket is empty, the output will be 0. The bucket, we won't get any output in the bucket if the bucket is empty. Say from the network perspective, leaky bucket consists of finite queue. Leaky bucket consists of finite queue where all the incoming packets are stored in case there is a space in the queue. Whenever if the bucket is empty, then it's going to store it. Otherwise, the packets are discarded. Means if overflow takes place, then it's going to discard the packet. So in order to regulate the output flow, leaky bucket transmits one packet from the queue in a fixed time. So we'll get the output in a regulated flow manner. In order to regulate the output flow, leaky bucket transmits one packet from the queue in a fixed time. For example, at every clock tick. For every clock tick, assume that here it's second. For each second, it's going to send one packet from the bucket. So while leaky bucket eliminates completely bursty traffic by regulating the incoming data flow. Okay, here, if it is bursty intake is there from the host computer, then if whenever its bucket is empty, it's going to store all that packets. But the main drawback is that it drops packets if the bucket is full. If the bucket is full, obviously, whatever the additional packets will come, it will discard that one. Also, does not take into account the idle process of the sender, which means that if the host doesn't transmit the data for some time, the bucket becomes empty without permitting the transmission of any packet. So if no incoming from the host computer means obviously the constant output will be there from the bucket. After some time, that bucket becomes empty. Okay. So it doesn't take into account the idle process of the sender. Means the sender is not sending any of the data. Then after some time, the bucket becomes empty. Okay. The same concept. So for this concept, we'll write the program. Okay, here program for congestion control using leaky bucket algorithm. Here we are including standard input output and standard library header files we are including here. We are defining a function here, minimum function. Later in the program, we will use this. Define minimum x comma y. Okay, here two inputs are there, x comma y. Here, if x greater than y, here question mark here, if x greater than y, then minimum value is y. So obviously, if x is greater than y, it indicates the y is minimum. Y will get the result. Else case will get x is the result. X is minimum. Okay, this function we'll use it in the program. That's why we are defining in the beginning itself. So we are defining minimum function here to find out the minimum between the two numbers. Int main, and we are initializing the value here, integer, O rate for output rate, drop equal to 0. Okay, here you assume the leaky bucket. Drop, that output dropping packets or 0 in the beginning we are assuming. Here the cap is nothing but the bucket size. Cap is bucket size. X we are defining. Count equal to 0 in the beginning. And input to 10. Means in the beginning we will assume that the size of the bucket is 10. The bucket can occupy 10 packets. The maximum size of the bucket is 10 packets. For all the 10 inputs, we are initializing with 0. I equal to 0 and n second. Okay, later we'll use for each second how many packets it's sending. In order to store that, we are using the variable name is n second and ch. Okay, later this variable we'll use it to store the value of 1 and 0, whether to continue the process or to stop the process. In order to indicate that we'll enter either 1 or 0. In order to store the value of 1 or 0, we are using this ch. Okay. So first we are initializing in the beginning, printf, enter the bucket size. So whatever the bucket size we are going to enter, we are storing that in cap. Okay, here the cap, we are getting the bucket size. Printf, enter the output rate. Okay. That output rate, whatever the output rate we will mention here. For example, for 1 second, if you want to send 2 packets at a time or 3 packets at a time, so that details we need to mention it in O rate, output rate. Here the size of the bucket is 10 and output rate is 2. Okay. For each second, the output, the 2 packets will go out at a constant time. For each second, 2 packets will go out. That output rate we need to mention. Let's assume that that output rate is 2 here. the bucket size is 10. Do printf enter the number of packets coming at second. Enter the number of packets coming at a second. Say from the host computer, how many packets are coming for each second, we need to mention. So because the bursty input will be there, here for 1 second, we may get 2 packets, 5 packets, or even more than that. Okay. So we need to enter the number of packets coming at second. Okay. That I plus 1. Scanf, and that value we need to store that in input of I. In the beginning, we stored a total 10 inputs. So whatever the first data we are going to enter, that data will be there in this input. So assume that in the beginning you will enter the number is 3, then first value it will take it as 3, and second if you are entering 4, then the second packet, the total number of packets we are getting at second time interval is 4. Like that it will keep on store the packets in the bucket. So print enter the number of packets coming at second, and the same thing you store that in this variable input I plus plus. Printf enter 1 to continue or 0 to quit. Okay. So if you want to stop the program, okay, so for example, in order to stop the input to the bucket, either you enter 1 to continue or 0 to quit. So because we know that the size of the bucket, if more number of packets will come at an interval, then always the spillover of packets takes place, the loss of packets takes place. So then depending on the size of the bucket, we need to accept the input. Enter 1 to continue or 0 to quit. That value we are storing that in ch. If ch equal to 1, it indicates we are keep on storing the values in the bucket. If 0 means we are stop storing the data in the bucket. While ch, if ch is 1, then only it's going to execute this one. If ch is 1, then it will execute it. If it is 0, it won't execute this. Okay, that's while condition. With the 10 second, we are initializing I here. Printf second, received, sent, dropped, remained. So assume that for the first second, second one, how many packets we received, we need to mention it here. Assume that for first second the received packet is 3, then sent packet, that output rate, it should be same here. That output rate, whatever the rate O rate we will mention, so it will keep on sending that number of packets to output to the network. Okay, so if it is 2, if the received packet is 10 also, then it will send only 2 here. Then dropped packet, if it is spillover, lost of packet, that dropped packet we need to mention it here. And the remained, if the received is 4 and sent is 2, the remained we need to mention it here. Okay, we are printing this headings: second, received, sent, dropped, remained. For I equal to 0, count. So this is a logical OR symbol. Count logical OR of I less than n second. Means if any one of the condition is true, then it's going to execute this. Okay. For I equal to 0, and for which particular condition we need to execute this loop, it's mentioned here. So in the beginning, the count we stored 0. This logical OR symbol, I less than n second. If I less than n second, then I plus plus. Okay. So in this case, we need to mention the values of this: second, received, sent, dropped, and remained. Printf percentage of d. Here, first we are printing the second. Okay. Printf percentage of d, the second. In the beginning, the second is 1, and printf tab will get this percentage of D here in received column, we'll get it. Percentage of D tab, input of I, input of I. How many inputs, how many packets we received, we need to print it here. Then sent items. So we need to print the sent items here. Here, that sent items that depends on the output rate. But here we need to check the input as well as count. Then only we can mention the sent items. For example, if the output rate we mentioned 2, if only one packet is there in the bucket means it's not possible to send 2 items, then we'll get only 1. That's why here in order to print the sent items, we need to find out the minimum value. Printf percentage of the minimum of input of I plus count, comma or rate. Here, which one is minimum? We are going to print that one. So in this case, that output rate, if we mention 2, and this value is more, input of I plus count. Okay, input of I is 4 and count value is 1. Always in the beginning, we'll get this output rate only. Only at the end, if less than the output rate, then we'll get this input of I plus count. So first, in the beginning, we are going to get only this output rate. If output rate we mentioned 2, the sent items will get it as 2. Okay. So in order to understand this, let's see the output once, then we'll come back to the program. Okay. Here, first we'll enter the bucket size. Bucket size is 10 and output rate is 2. Enter the number of packets coming at second one. Assume that number of packets coming at second one is 3. Enter 1 to continue or 0 to quit. If you enter 1, then once again it will take at second 2, number of packets coming 4. Similarly, you continue by pressing 1, then it will store this packet in the bucket 5. Here we pressed 0 here. Then it's going to print these values in the second. Total 1, 2, 3, 4, total 9 seconds. Received. In the beginning, we received 3, then 4, 3, 2, 5, 0. 3, 4, 3, 2, 5, 0. Sent item. Here, the output rate, depending on the output rate, we'll get this sent item is constant here. The regulated flow will be there in leaky bucket algorithm. So in the beginning, it's 2 only. And dropped, if it is more than 10, if the remaining is more than 10, then only this dropped values will get it here. Otherwise, if it is less than 10, if the remained is less than 10, then dropped will get it as 0 and remained here. In the beginning, we received packet is 3, sent is 2, remained is 1. Next, received is 4. The remaining in the beginning, remaining is 1. So total 5. 5 minus 2 means 3. Like this, we are going to print the remained packet in the bucket. So at the end, if it is here, the packet received is 0 here and remained packet is 1. So the sent item will get it as 1 here. Okay. So this is the output we will get for this program. In the same way, we are going to print it. Okay. For this, we need to write the program. Okay, here. First, we printed the second. Next, we printed that input, the received input. Next, based on the minimum value, we are printing the sent statement. Next, we need to find out this dropped and remained. We need to find out the dropped as well as this remained. If the count value less than the bucket size, the remained value less than the bucket size, then we'll get drop equal to 0. Then in the remained, whatever the received packet and the sent packet, after that, whatever the remained, we need to print that one. Okay. So here, so this is the statement we need to print it, and the same values we are printing in the print statement. First, we are printed second, next received, next sent items based on this minimum value. Next, we need to find out this dropped and remained. So in order to find out the drop and remained, we are checking this condition. if x equal to input of I plus count minus output rate greater than 0. Okay. We need to check this condition first, that input of I plus count minus output rate, if it is greater than 0, then if x greater than cap, that x is greater than cap, greater than the size of the bucket. If x is greater than the size of the bucket, then count equal to cap and drop equal to x minus cap. So we need to consider different cases here. If x greater than the cap, then count and drop will get these values. Count equal to cap and drop equal to x minus cap. Else case, if x less than cap means, then count equal to x and drop equal to 0. Okay, now we will get this condition. Drop equal to 0. Count equal to x, drop equal to 0. Else case, okay, if x greater than cap, this is the condition. If less than cap, then this is the condition. Else case, we are assigning 0 for drop and count. Then we are printing the drop value and the count value. Here the drop and count value is nothing but the dropped column. We are going to display the dropped items, and in the remained column, we are displaying the count values. Okay. Then return 0. So this is the sample output we will get for this leaky bucket algorithm. So this is the output for the program congestion control using leaky bucket algorithm. Okay. So first we need to enter the bucket size, enter the output rate, then how many packets entering into the bucket, that we need to mention it. We are getting 3, 4, 3, 2, 5. Whenever if you press 0, then it will stop taking the input values. Then we are displaying the values in this fashion. In the column fashion, we are displaying the second, received, sent, dropped, and remained. Okay. So in order to find out this, we are considering the different cases. Okay. So the second and received, we'll get it from here only. That sent items using that function, that minimum value we are finding out, and that value we are displaying here in the sent. And dropped, in order to find out this dropped, we consider two different cases, and the remaining values we are displaying here. So this is the output for congestion control using leaky bucket algorithm. Okay. So this is about fifth experiment in part B. Okay. Thank you.